All right, looks like we have Trig lecture 9.8, 9.9, and 9.10. So we're going to do this for 3 days. The student will use trigonometric ratios. Ratios are little fractions. Trigonometric means we're going to use trigonometry to find the measure of an indicated angle. So we're looking for the measure of an angle given a right triangle. So they're going to give us a right triangle and they're going to ask us for the measure of a specific angle. So here we go. Let's take a look here. Review of rounding to the nearest tenth. Well, we're going to be rounding all of our answers to the nearest tenth because that's what our instructions are going to say. And a lot of times kids forget how to do that. I've had over the years a lot of kids say, wait, I've forgotten how to round. So I'll just give a quick little review of rounding. Review of rounding to the nearest tenth. The tenth is the first decimal place to the right of the decimal. So if I'm asked to round this to the nearest tenth, I'm looking at this, and then I look immediately to the right. If this number is a 5 or bigger, we round up. If it's a 4 or less, we leave it alone. You never round down. So we would round this to 32.7. And that would be an approximation. That's what the little squiggly equal sign means, approximately. Or here's another way to write approximately. Have an equal sign with a dot above it. Both of these mean approximately. Okay, now I'm going to round this one to the nearest tenth. Here's the tenth right here. I look immediately to the right. If this is a 5 or bigger, I'm going to round this one up. So it'll be 32.8. And that's an approximation. So if we look to the right and it's less than 5, we leave it alone. If we look to the right and if it's 5 or greater, we round it up. Okay, let's take a look at a couple more. And these will be approximations, of course. 105.01. If I want to round this to the nearest tenth, I'm going to say 105 point. I'm either going to round this up or leave it alone because this number here is less than 5. I'm going to leave it alone. There's an approximation for this value rounded to the nearest tenth. Looking at this one here, same basic number, same type of number, rounding to the tenth. I'm going to call it 105 point because this is a 5 or bigger. I'm going to round this up. It goes up to a 1. And that's an approximation. Okay? So rounding to the tenth, this is not rounding up, and this is rounding up. Never round down, okay? When you're rounding to the nearest tenth or any other. Okay, here we go, 43.96. I'm going to round to the nearest tenth. So I'm going to call that, when I round this up, because that's a 5 or more, that's going to turn into a 10. So I'm going to say, and carry the 1. Okay, 10. This rounds into a 10, I carry the 1, so that'd be 44.0. If this is a 9 and then I round up, write the 0 down and carry the 1, just like when we were adding when we were little. So 43.9623 will round to 44.0 when rounded to the nearest tenth. 43.90, we're again trying to round to the nearest tenth. Because this is a 4 or less, we're not going to round this up. We're going to leave it right where it is. And that's a little review of rounding. So here we go. Find the measure of the indicated angle, round to the nearest tenth. Well, we've got triangle ABC. It's a right triangle. And I'm asked to find the measure of the indicated angle. That is theta. That's the angle they're asking us for. And we want to find the measure of it. So I look at this and I say, well, I've only got 2 of the sides given. I don't need all 3 sides. I just need to find a trigonometric function that deals with these 2 sides from the perspective of theta. So I ask myself, well, will the sine function work? The sine function is opposite over hypotenuse, so I don't want to use sine. How about the cosine function? The cosine function is adjacent over hypotenuse. I don't know the hypotenuse, so I don't want to use that. How about the tangent function? Tangent of theta is 4 over 8, so that's what I'm going to use. And I'm going to stick with sine, cosine, and tangent because I'm going to be using my handy-dandy pocket brain. And it has sine, cosine, and tangent buttons on it. So I'm not going to mess with secant, cosecant, and all that good stuff. Here we go. I'm going to make a statement the tangent of theta. I chose tangent because I have the opposite and the adjacent that I can work with. I can say the tangent of theta is equal to 4/8, opposite over adjacent. Now I'm looking for the measure of theta and I want to round it to the nearest tenth. So what I'm going to do is I'm going to take the inverse tangent of both sides. And we have a button. You guys will be using a calculator probably that looks like this one. And so to use the inverse tangent, we're going to say theta, that's the measure of the angle we're looking for, will be equal to the inverse tangent. Here's the symbol for it. Oops. I said here's the symbol for it, and then I didn't write the symbol for it. That little -1 looks like an exponent, means the inverse tangent of theta, and, I'm sorry, not theta, of 4/8. There we go. And if I can get this into my calculator, it will tell me the measure of that angle. So we took the inverse tangent of this side and got theta. Take the inverse tangent of this side, we get the inverse tangent of 4/8. We're going to try to figure out how to put that in the calculator. So here's how we would do it. Clear our calculator, hit second function, and look at the tangent button. Up above it is a little function for the second function, is tangent with a little -1. That's the inverse tangent function. So we're going to hit it, and it's going to display tangent, inverse tangent with an open parenthesis. We're going to put our fraction, 4/8, in there. You can use the fraction button, or you can use 4/8, either way. And then remember to close your parenthesis. Close the parenthesis, hit enter, and that gives us theta is equal to about 20, that's supposed to be a 2, 26.5650518, and it goes off the display. It goes on forever. But I want to round this to the nearest tenth. I see that the number to its immediate right is a 5 or bigger. It's a 6, so I'm going to round that up. So theta is approximately 26.6 degrees. So if I'm given a triangle and I know that this is 90 and this is 8 and this is 4, then this would be very close to 26.6 degrees. And we can make this as precise as we want it to be. We just chose the nearest tenth because that's what we were asked to do in our instructions. Now let's take a look at another one. Try not to, oh, let me make sure I got it right. 26.6, yay. All right, let's take a look at another one. Okay, I've got triangle ABC again. Got my handy dandy pocket brain ready. I'm going to say, okay, which function am I going to use? From here, if I use the sine function, I would use opposite over hypotenuse. So I'm going to use the sine function. I'm going to try to see if I can use sine. If not, I'll try to use cosine. If not, I'll try to use tangent. Up above, I had to use tangent because I had the opposite and the adjacent. Here I have the opposite and the hypotenuse, so I'm going to use sine. I'm just going to make the statement, the sine of theta is equal to 7/14. Therefore, theta is equal to the inverse sine of 7/14. Therefore, theta is equal to, and let's see what we get. I'm going to clear it, hit second function and sine. That displays the inverse sine function with an open parenthesis. Inside the parentheses, I'm going to put the fraction 7/14, 7 divided by 14, or you could use the fraction button. Remember to close your parentheses, hit enter, and it says exactly 30. I don't have to round this to the nearest tenth. That is exactly 30 degrees. If this is 14 and this is 7 and that's a 90-degree angle, that angle right there is exactly 30 degrees. Didn't have to round it at all. Okay, and let's see if I got that right. Yay, 30 degrees. All right, let's take a look at one more. Doing the same thing. looking at this, I asked myself, well, can I use the sine function? I've got a right triangle. Here's the angle, my indicated angle. Can I use opposite over hypotenuse? No. Can I use adjacent over hypotenuse? Yes, so that's the cosine function. So I say, well, the cosine of theta is equal to 5 over 9. Therefore, theta is equal to the inverse cosine of 5 over 9. I'm going to take my handy dandy pocket brain, clear it, oops, I hit the wrong button, clear it, and hit the second function, cosine, 5 over 9, close the parenthesis, okay, so opens, you put that in there and then close the parenthesis and hit enter, and then round it to the nearest tenth. This gives me a display of 56.25101114. It goes off my display, but it goes on forever. And I'm looking for the nearest tenth. So I'm going to say that theta is approximately equal to 56.3 degrees. Again, if we're given a right triangle and we know that the adjacent side of the angle we're looking for is 5 and the hypotenuse is 9, we can find that by taking the inverse cosine of this ratio, 5 over 9. So we can use the tangent function if we're given opposite over adjacent. If we're given, from the perspective of the angle we're looking for, if we're given opposite over hypotenuse, we'll use sine and inverse sine functions. And if we're given the adjacent and the hypotenuse, we'll use the cosine and take the inverse cosine on both sides. Rounding to the nearest tenth. Let's see if I got that one right. 56.3, yay! You can do this.